Eyes forward, hands free. A rugged computer that goes with you in the most challenging environments. I'm Tonya Hall for ZDNet and Tech Republic, and joining me is Andy Lowery. He is the CEO of RealWear. Welcome, Andy.
Thank you. Looking forward to it.
So tell us about RealWear and what you do there.
So the heart at RealWear, we're a knowledge transfer company. So we help in situ training and that sort of stuff through the production of this device you see I'm wearing on my head. What I have here is what we call the HMT1, which is a head-mounted computer, tablet grade, powered by Android, like a lot of tablets that are getting deployed into industry and stuff that are being deployed today. And it's worn versus held. And so in that case, we use a voice layer, our software, to control the device and allow you to navigate through different menus or different applications with your voice. In this way, you can be eyes forward, hands free, very safe, but it's still a very intuitive way to share information either between a machine trying to tell you how its temperature or pressure are doing, or an expert that might be 1,000 miles away that wants to coach a young technician through a maintenance procedure, an operational procedure. So that's what we do at RealWear.
So I have to say, it looks pretty interesting. You look great. So, but where's the screen? I'm trying to understand where you can actually visually see the screen in the monitor.
That's a great question. So if I'm climbing up a tower or something like that, I don't want anything in front of my face at all. I want to have complete situational awareness. But when I get in situ and I have to do my job, I bring out this guy that looks a little bit like an NFL coach's Bose microphone, and it is a microphone. This is a microphone, but it's also a display. So underneath my eye here, I have a little dashboard that appears to me to be about the size of a 7-inch tablet held at about 25 inches away. So as you hold a tablet normally in about the same distance, I have about a 7-inch tablet as far as real estate goes to display information. Very similar to what you'd see on an Android tablet. And I'll give you a short demo here. About the only thing that you can see that I can do with the device is I can do this. Flashlight on. So you see, I control it all through my voice. So I might be in a dark spot. I can't see what I'm doing. I need all of a sudden a little bit more illumination, but my hands are deep in a machine or working on some sort of a procedure. I need my flashlight on. I can just control it with my voice. Now, flashlight off, flashlight on. And you see, and this is the way we drive our system through the voice. Flashlight off.
That's great. I mean, it certainly relieves having a physical assistant right next to you. In fact, I kind of had a flashback to Dad working on the car, and he's telling you to hold the flashlight above him. That's certainly an interesting tool.
You know, those were some crazy. My dad did the same thing, and I said, "Dad, you're not making me want to work on cars by yelling at me every time you make a mistake that I'm not holding the flashlight right." So spent the rest of my life building this system so that he can have his own flashlight.
Explain the Industry 4.0 connected worker concept. I mean, how it merges IoT, AI, XR, and robotics.
Sure. So the idea of Industry 4.0 is really an application of our information age. So we're moving deeply into the information age right now. And what we see in Industry 4.0 is an application of the information age to industry. So what I mean by that is it's a paradigm for sort of connectivity. So we're connecting data, machines, and people. And you can think of that as simply as a smart stove that might have data on the temperature of the food or if something's burning and can go up to the cloud with that information. And you could be completely in a grocery store, not even near the stove, and receive an app alert on your phone that says, hey, the stove is having problems, and you shut down the stove remotely. So that connectivity is connecting data, the temperature of the stove, the machine, the stove itself, and the person in the grocery store that's remote now monitoring their stove. So that connectivity triangle is being sort of very much adopted by industry at whole and at large. And where we fit in is we are that connection hub to the person. We are the industrial connection hub to that data and those machines. And by having this hub that's very rugged, but very safe and very sort of orientated towards an industrial type of a job versus more of a consumer type of a product, we're able to be very, very effective in that sort of connectivity with workers or people performing work.
To your point, Andy, designers of industrial technology need to enable the transfer of knowledge from those who have it to those who need it. Why is that not as easy as it sounds?
Well, it's interesting. My former job, I was a business area chief engineer at Raytheon, and we used to always kind of think about an analogy where we may need to make a decision, and it's a yes-no decision. It may be a decision to RF jam a target, for example. Should we put jamming energy on that target? Well, the decision to do that is one bit. It's just one bit. It's a 1 or a 0 in a computer. But the data behind making that decisions can be terabytes upon terabytes upon terabytes. So everywhere in the world, this similar type of thing is prevalent, that you have reams and reams of data. But the people that need to make the decision on the front line are confused by all this data unless the data can be pared down and delivered in sort of bite-sized chunks. This is what you should do. This is the operation that needs to be performed. In order to convey that information, you need devices. You need edge devices. You need computers on machines, or in our case, we put computers on the actual frontline workers. We say, save the machines from the computers. Let's put the computer on the worker, because every machine needs some kind of interaction with a frontline worker. Well, by putting the computer on the person, you flip sort of that paradigm where I don't have a natural language orientated machine connected to a steam generator. I have a cloud file or data coming from that machine and being sort of processed on the computer that I'm wearing. It's a different way of looking at it, but it's the same type of information transfer that we're trying to get to. On the front line, sitting there in front of machines, working out there in various different locations or environments.
Why did you select Android?
So Android is, quickly becoming the world's most ubiquitous operating platform. And in the US, it lags, but overseas, Android's really, really kind of moving quickly. And we had to be a global company. We are very deep into the business frameworks in China. We've taken a lot of work into Europe and also in the United States. So we had to have a platform that had some amount of ubiquity across the planet. And we were trying to leverage what's going on right now as far as this digital sort of transformation. And a lot of the applications nowadays are being built on Android. If we were to go with a Apple, let's say iOS type of operating system, it's very proprietary and closed. And so we're not able to manipulate that software. Apple keeps that sort of locked tight in-house. If I were to go with a Microsoft platform, I had limitations on some of the mobile technology because Microsoft has been a little less prevalent with the Qualcomm types board support packages that are supporting the operating system for Windows 10 and stuff. So we had to select something that was mobile in its orientation, being quickly adopted globally in industry, and we chose Android. Now, to say that we can't use a Microsoft operating system in the future is not true. We could absolutely design a future device or even on this device with other operating systems like Microsoft, but we chose to start with Android.
How does RealWear work with Android developers?
So we have a whole ecosystem of various application partners. And so we look at our business like a lot of other sort of platform-based businesses, that for every dollar we make, we'd like to see the ecosystem collect $9 of profit. And we do that by a very sort of robust, I'll say, integration program where if you're an application programmer that knows how to work in Android, that's all the information you really need to know in order to use our device or to develop applications on our device. So early on, we gave early access to some key partners like Honeywell, partners like LibreStream, partners like Intoware. These are our application ecosystem partners that are actually driving sort of the value or the solution out there in the space. And so we're very much like the Apple meets industry model in a wearable format where we do the OS, or at least the layer that sits on top of Android that does the voice control and all that. And our ecosystem provides the application and sometimes the cloud services that actually support the overall solution as they're deploying.
Security, hacking, that's constantly a concern. How are you approaching this? I'm sure is being used in some very sensitive and complicated situations. How are you protecting the technology and the user?
Yeah, it's interesting and a great question because I come from the world of Raytheon. In fact, I was the business area chief engineer over electronic warfare, which contained the subfunction of cyber. So I'm very familiar with sort of security systems and protocols. And truth be told, Android has come a long way. I mean, back in Android early days, it had many security vulnerabilities. By making an open system like Google chose to do, they had an open system that was sort of plagued with these backdoors and holes and ways that they could be, attacked on an Android system. Whereas a proprietary system like iOS, they have much more control of all of that. Well, since then, we're all the way up to Android 8.1, and the security on that version of Android is robust. The DoD currently uses Samsung phones on a number of different applications. I mean, this isn't any longer Android's not secure enough for even classified information. A lot of times, though, we are running up against companies who haven't initiated sort of the process to accept Android yet in their overall system. So that's been a slowdown from time to time. But what we're finding is that most companies, at least our customers, are now trusting Android as an operating system, especially at 8.1 and higher. They're absolutely trusting Android to be secure enough to connect to their overall networks.
What's next, Andy? What do you see as the next big breakthrough for augmented reality?
So I think augmented reality is, and I started my journey on augmented reality by being the co-founder of another company called Daiquiri. And Daiquiri started out as a AR specific company that we were going to put AR in industry, we were going to change human machine interfaces, and we were going to do that in an immersive way. And what I found at Daiquiri is that a lot of applications in the maintenance, repair, and operational side of the overall equation are in locations and environments that are much too dangerous to put an immersive system in a digital layer. So in training applications and maybe safe manufacturing locations, a Microsoft HoloLens is a fantastic product. But when you're climbing up a telephone pole or you're out at sea on a oil platform in the North Atlantic, it's not such a great device, not waterproof, not robust, not rugged. And most importantly, how I'm wearing it now, and even when I was wearing it before with it down below my eye, it allowed me to maintain full situational awareness. So what we've done at RealWear is we've led with safety first. Eyes forward, hands free. Then how do we convey that information, convey those applications in a way that maintains that situational awareness and that safety? Because our target audience are maintenance, repair, and operators on the front line in dangerous industrial situations. So the product's a lot different than the AR that you see at HoloLens, but at the same time, we feel that over time, we will go more and more immersive, but we will maintain the safety aspect and never fall back on safety. In fact, I was talking to John Waldron about 6 months ago about this, and Honeywell has a very interesting philosophy. They showed me a Cartesian coordinate with safety on the y-axis and productivity on the x-axis. He drew a curve, and he said, Honeywell never does anything that doesn't move the curve outward in both dimensions, x and y, safer and more productive. That's also RealWear's philosophy. So as we move into more immersive systems or even more prosumer systems that we're doing indoor use, outdoor use, hospitals, medical, that sort of thing, we will always maintain the idea that until the technology is ready and can be safe and basically eliminate sort of a user interface and a feeling of having to have something sort of blocking between you and the real world, we will continue to step slowly into the overall immersive augmented reality market. But I do believe it's going to be that. It's going to be much more immersive and much more sort of integrated with reality as the technology improves.
Andy Lowery, CEO of RealWear, thank you so much for joining. If somebody wants to find out more about your technology, maybe they want to get some for their company, or maybe they just want advice from you, how can they do that?
Well, they can do that by just going to www.realwear, and that's spelled W-E-A-R, not like software, like a wearable, like I'm wearing. So realwear.com, and we have a number of forums or emails there that you can get a hold of me from.
Thanks again. And if you guys want to find more of my interviews, you can do that right here on ZDNet or Tech Republic, or maybe find me by going to tonyahall.net. I've got links to all my social sites. Thanks for watching.
Thank you, Tonya. Thank you.